Continuing on with the here for the Unit 6 exam, number 5. This is kind of a throwback to last chapter where we did our sequence generators, but a bank is offering a special college savings plan for families. For every one-time investment of $1,000, the account will gain 10% interest every year. If a family starts a plan with $1,000, answer the following questions. What is the sequence generator? So first we need to kind of think about let's do it in the order that it asks. So I see that I'm gaining 10% interest. So my sequence generator, or we kind of refer to it more as the multiplier in our class. If I go to the bank and I hand them over $1,000, right, 100% of my money, after a year, they're telling me they'll give me 10% interest. That means they're going to return to me 100% of my money, plus they're going to give me interest, which is an additional 10%. So that means after the year, they're going to give me back 110% of my money. So my multiplier is 110%, but I can't put something with a percentage symbol into my equation that I'm going to use. So I have to rewrite this as a decimal, right? So 110%, percent means divide by 100. So I would move the decimal to the left twice. So 1.10, that's a number, a decimal that represents 110%. So my multiplier is 1.10. Write an explicit equation. So I don't want us necessarily to be writing, the explicit equation of a sequence. I want to think of this more like we practiced in class, right? We said y equals the initial amount times the multiplier to the x power, right? And this is a sequence. The initial amount would be t of 0, and the multiplier would be the r. It's really the same thing, but I like to think of it this way. So for this problem right here, y equals the initial amount was $1,000 times the multiplier, which we said was 1.10 to the x power. Part C, find the value of the savings after each of the first 4 years. Write a recursive equation. So again, I'm going to not worry about the recursive equation too much. I want to make sure we understand how to actually put these in and solve them. So pulling my calculator up on the side here because I know I'm going to need it. So to solve this equation right here, we want to know how much is in there at 4 years. So that's the exponent. So I'm going to fill in a little table here. I could do this year by year in kind of that recursive fashion, but I want to practice using this formula because it can be more useful down the road. So I know when x is, let's plug in a 0. When x is 0, let's make it a different color. When the x is 0, then I'm going to write my equation, y equals 1,000 times 1.10 to the x power. If x is 0, what am I going to get out? Well, anything to the 0 power is 1. So that would be 1,000 times 1. So at year 0, I have $1,000. That makes sense, right? After 1 year, y equals 1,000 times 1.10 to the x power, but here x is 1. So if I plug that in my calculator, or I just multiply it by their one time, I'll end up with $1,100. Kind of running out of space here, so I'm going to kind of just do this again. At year 2 and 3 and 4. We're really going to do the same exact thing every time, right? Y equals 1,000 times 1.10, and the exponent is the only thing that's going to change. So to know how much is in there after exactly 4 years, I could do this for any of them. I'm going to just solve the last one for the sake of time. I'd have 1,000 times 1.1 to the 4th power. I plugged that in my calculator here on the side, and I just got $1,464.1. So I have another 0 for money. It's not bad for 4 years. Free $464. All right, moving on to number 6. Number 6, Jonah orders pizza from Little Caesars every week for his coworkers. 1 week he orders 4 thin crust pizzas and 4 deep dish pizzas, and it cost him $58. The next week he orders 6 thin crust pizzas and 3 deep dish pizzas, and that week cost him $63. After paying for the pizzas, he's curious, how much does each pizza cost? Could check the menu, that would be one option, but maybe he doesn't have a menu, so he's going to write a system of equations to determine how much each one costs. So again, our first thing we want to do in a word problem is define our variables. So we said in class, whenever I have a word problem, it's going to ask me something, and that something that it's asking me to find is or are the variables. So after paying for the pizzas, he's curious how much each pizza cost. So determine the cost of a thin crust and the cost of a deep dish. So those are the two things we don't know. So I'm going to say X is going to be the cost of a thin crust pizza, and Y is going to be the cost of a deep dish pizza. So now I can write a system of equations. There looks like there's going to be one equation for each week. So the first week there's 4 thin crust pizzas. So I have 4 pizzas, and each one of them cost X dollars, and 4 deep dish pizzas. So 4 of those, and they each cost Y dollars, and the total was 58. In the second week, right, he orders 6 thin crust pizzas and 3 deep dish pizzas, and the total that week was $63. So we identified and defined our variables, and then we wrote a system of equations. Now we're just solving like always. So again, X and Y on the same side both times. This is prime example of when we want to use the elimination method. But if I look here, I'm going to add these together. That's my goal. But if I add these here, I'm going to get 10x down here, and I'm going to get 7y there. Nothing's going to go to 0. So I need to choose which one I want to try to eliminate. Just for the sake of simplicity, I'll go with the x's. Why not? Doesn't really matter. So I'm going to eliminate the x's first. So that means I need to get the x's here when I add them to add up to 0. So I know 6 and 4 both go into 12. So my method is going to be to turn them both into 12, one positive, one negative. So I'm going to multiply this top one by 3, and that would make it a 12. And I'm going to multiply the bottom one by 2, but a negative 2 to make it negative 12. That's going to work nice, and then my x's will cancel. So what I do to one term in an equation, I got to do all of them. So if I do this first term by 4x by 3, I got to multiply all of these by 3 and all of these by negative 2. And if I move these over, I got 12x plus 12y equals 116. And on the bottom, negative 12x minus 6y equals negative 126. So I just manipulate my equations. Now I'm going to add them together. So 12x and negative 12x is a 0. 12x and negative 6y. Oops. I'm recognizing here I made a mistake, so I'm going to fix it. Right, this number right here, when I multiply 3 times 58, I did 2 times 58, so that's 150 plus 24, that's 174. So that's a good example, right? I started to get close. I recognized I was going to end up with a negative. My variable was going to be a negative, like y equaled a negative number. And remember, y is the cost of the deep dish pizza. So these should not come out to be negative because you're probably not paying negative money for the pizza. So I caught my mistake there. I had done that incorrectly. So 12y minus 6y is 6y. And now over here, 174 minus 126 is 48. So 6 times y is 48. Divide both sides by 6. The y equals 8. Right? That means the cost of the deep dish pizza is $8. But I'm not quite done because I need to identify the cost of the other pizza. So I take any equation I want that I've used so far. I'm just going to take this green one. 4x plus 4y equals 58. And I know that the y is 8. So where I see the y, I'm going to plug in an 8. So 4x plus 4 times 8 is 32 equals 58. Subtract 32 from both sides. Right, subtract 32 and I get 26. And divide both sides by 4. And I get 6 1/2, 650. If I do my math with the calculator, or I take half of 26 and get 13 and then take half of that. So we actually end up with the decimal here. That's okay. Most of our problems, have been pretty friendly, but this tells me the cost of a deep dish pizza. And, right, so my solution, I should probably write my solution this way. All right, that's what we've been practicing. It's an ordered pair, right? They happen at the same time. All right, we've got one more problem. And I'll just do it in the same video here, and I think that's okay. So as a treasurer of her school club, Amy is trying to figure out how many t-shirts and how many sweatshirts she should order for a fundraiser. She knows that in the past, the number of t-shirts sold are 3 times the number of sweatshirts. T-shirts cost $18, sweatshirts cost $27. If Amy has $486 to spend, how many t-shirts and how many sweatshirts need to be ordered? See, this is going to be a little bit trickier, but we're going to follow our same procedure, right? It asked me here in the question, how many t-shirts and how many sweatshirts? So that's my two variables. X is going to be number of t-shirts, and Y is going to be the number of sweatshirts. So if I look closely, well, okay. Now that I should have looked closely. Now that I look at the equation, or at the graph, I should say, they've already got it labeled and they have it the other way. So you can label it however you want. This one's already labeled on the graph, so I'm just going to make Y the t-shirts and X the sweatshirts, so it matches the graph over there. All right, write the system of equations. So we're going to examine our sentences here. So she knows in the past, the number of t-shirts, okay, that's Y, is, that means equals, 3 times, so 3 times means multiplication, the number of sweatshirts, which is X. So Y equals 3X. That would be a good equation from that first sentence. we know each sweatshirt she buys, I'll do a different color here. So X, every sweatshirt she buys costs $27, and every t-shirt she buys cost $18, and the total she has to spend is $486. So how many could she buy? This is kind of a tricky problem here, so let's see. I think we wrote our system of equations, so now we want to graph it. So let's graph the first one, because that's easy. So y equals 3x plus 0. So I can graph this one pretty easily here. So 3x plus 0, I know my y-intercept is 0. And then check my scale. These all go by 1s. That's good. So I'm going to go up 3 over 1. Up 3 over 1. Something like that. I probably should not connect these dots because these are whole number items. I can't buy half of a sweatshirt or part of a sweatshirt. I can only buy 1, 2, 3, 4 sweatshirts. So my domain is only going to be integers. So that's the first one. The second one's a little bit trickier though. Right? So I have to solve for y. Right? So for this equation right here, if I want to graph it, I don't have to, but I'm going to solve for y. That's the best way, the way we really learned how to do it. So I'm going to subtract 27x from this side and do the same thing over there. So I'm going to end up with 18y equals negative 27x plus 486. And then I'm going to divide away the 18. And if I do it to 1, I got to do it to this one and this one. So I would end up with y equals negative 27x over 18. So I can reduce those by 9. So that'd be negative 3 over 2x plus, and if I reduce this fraction right here, 486 divided by 18, that would be 6 would go into that 3 times, and 6 would go into that 81 times. And 3 goes into that 20, so this comes out to 27. So if I reduce 486 divided by 18 is 27. So my y-intercept is 27. So 25, 26, 27. And that one goes down 3, 1, 2, 3, over 2. Down 3 over 2. Zoom in a little bit here. Down 3 over 2. Oops, I see a little overlap there. 1, 2, down 1, 2, 3 over 2. So if I want to know, right, the solution to the system, solve your system using any method, right? Well, it asked us to graph them. So, I mean, I already graphed them. I see they cross right here, right? So that's my solution right there. I could use any of the other methods that we have learned, but I mean, graphing's already done for me. So that's going to tell me the solution right there, which, let's see, it's a little bit difficult to see. All right, so the x is 6 and the y is 15, 16, 17, 18. So my solution is 6, 18. All right. So what does that mean? X was the number of sweatshirts. So, all right, so she needs to order 6 sweatshirts and 18 t-shirts.